Welcome to Chapter 4. In this chapter, we're going to talk about factors and prime factorization. Let's start with factors. Factors are numbers that multiply to make a number. So, for example, the factors of 15 are 1 and 15 and 3 and 5. The first part of your work is going to ask you to identify the factors. Let's find the factors of 10. We're going to make an organized list, and I like to think in an organized way, so I'm going to start with 1. 1 and 10 make 10. Now 2, does 2 go into 10? 2 goes into 10 5 times. 3 does not go in, 4 does not go in. I'm going to stop right there because we already used 5. Let's try 30. I'm thinking all the different ways to multiply to make 30. Again, I'm thinking in an organized manner. I'm going to start with 1 and 30. Does 2 go into 30? Yes. 15 times. Does 3 go into 30? Yes. 10 times. 4 does not go in, but 5 goes into 30 6 times. Again, I can stop because I meet in the middle. Go ahead and try 36. Push pause and try 36. Organized matter. So I'm going to start with 1 and 36. 2 goes in 18 times. 3 goes in 12 times. 4 and 9. 5 does not go in, but 6 times 6 is 36. I'm not going to list 6 twice, I'm just going to list it once. If you do list it twice, it's not going to be wrong. The second part of your homework is going to ask you to identify prime and composite numbers. We wrote definitions for those in the past, so let me remind you. A prime number has 2 factors, 1 in itself. So an example of a prime number is 7. 1 times 7 is 7, those are the only 2 factors. A composite number has more than 2 factors. So an example of a composite number is 100. Think of all the different ways to make a 100. It's more than just 1 times 100. So they're going to give you a number and they're going to ask you to label it prime or composite. So I'm going to use these examples. All 3 of these are composite because they have more than 2 factors. This has 4 factors. This has 8 factors. This has 9 factors, so all 3 of these are composite. I'm just going to put a C after them. An example of a prime number is like 17. 17's factors are 1 and 17. It has no other factors. Because it only has 2 factors, it's prime. Let's talk about prime factorization next. This is a definition. Prime factorization is a whole number written as a product of prime factors. A whole number written as a product of prime numbers. We have learned 2 different ways to find the prime factorization in the past. One of the ways is called a factor tree, and the other is a ladder diagram. You get to choose which method you prefer. You do not have to know both. Prime factorization is taking a composite number and finding the prime factors of it. Let's try. We're going to try with 50. I'm going to start with the factor tree. Notice the label's on the left, so I'm going to do the factor tree on the left. To work with the factor tree, you need to think of 2 factors of 50. And I know there's more than 2 out there. I'm just going to use 5 and 10. Your tree, your limb, is going to stop if it has a prime number. 5 is prime because it's only only factors are 1 in itself. 10 is composite, so that limb has to keep going. Think of 2 factors of 10. When you get to a prime number, you circle it and that limb stops. Now I'm going to list the numbers from least to greatest. And this is listed as repeated multiplication. My final answer is going to have exponents in it. Most of the time it's going to have exponents. So there's only 1, 2. I leave that as a 2. Because there are 2 5s, a 5 gets an exponent of 2. So this also says 2 times 5 times 5. We just write our most completed answer from least to greatest and using exponents instead of repeating numbers. Let's try this with the ladder diagram. The ladder diagram is a little more specific, whereas the factor tree, we could use any factors, but with a ladder diagram, you can only divide by prime numbers. So I cannot divide this by 25 because it's not prime. So instead, I can divide this by 2 or by 5. I'm just going to take 2. Whatever number you're divided by goes on the outside, and then you do the division and that number follows underneath. Okay, get on dividing. Think about a prime number that you can divide 25 by. You can stop when you get a 1 at the bottom. Your prime factors are off to the side. Again, you're going to list them from least to greatest. And your final answer is going to have exponents in it. No matter what method you use, you're going to get the same answer. I would like you to try 120. You may use the factor tree or the ladder diagram. Push pause and try that now. I'm going to start with the factor tree and then I'll do the ladder diagram. The factor tree, it doesn't matter what factors you use it doesn't matter which factors you use as long as it's not 1 in itself. Okay, so I'm just going to choose easy one. When anything ends in a 0, I know I can divide that by 10. Neither of these limbs are prime, so I'm going to keep on rolling. I can use 2 and 6 here or 3 and 4. Circle the prime numbers, that side's down. Okay, now I've finished this guy. I'm going to list this from least to greatest. So it might help when you have a lot of factors to cross off the ones that you've already listed. My final answer is going to have exponents. So here I have 3 2's. Because there's only 1 3, I drop that down. Because there's only 1 5, I drop that down. You're going to get the same answers if you use the ladder diagram, but here's the difference. I cannot divide this by 10. I cannot divide this by 12. I have to divide it by prime numbers. So I see the easiest prime number to take out of 120 is 2. Now I'm going to continue that trend. I'm going to take out another 2. This time I'm going to take out a 5. And it doesn't matter if you do 2 or 3, as long as you're dividing by a prime number. You can finish when you get a 1 on the bottom. Your answers are off to the side. I'm going to list them from least to greatest, and then with an exponent. Okay, here's the new portion. We're going to be factoring monomials. This is our new part. What is a monomial? It's a number, variable, or product of a number and one or more variables raised to a number of powers. A number, variable, or product of a number and one or more variables raised to whole number powers. So here's an example of a monomial. A monomial can be just a number, it can be just a variable, or it can be a product of a number and variable. So remember, when there's a number next to a variable, it means multiplication. So this is a product of a number and a variable. Here's another example. A product of number and variables, and one of the variables is raised to a power. Both of your variables can have an exponent as well, as long as all of those numbers and letters are being multiplied. This is not an example of a monomial. Think about why it's not. The 2 and the x squared need to be multiplying. It can't be sum, it's got to be a product of both of them. Our job is going to be to find the prime factorization of a monomial. So let's say they give us 36x to the 4th t. You are going to find the prime factorization of the coefficient of 36 the same way as we did above. You may use the factor tree or the ladder diagram. I'm going to use the factor tree. I like the factor tree because you don't have to worry about dividing by a prime number. There are multiple different ways to get the same answer. I'm going to list these from least to greatest. Okay, now I need to work with the variables, and I'm going to separate these variables. This exponent tells me how many s's there are. This t technically has an exponent of 1, so there is only one of them. This is as far as you have to go in this section because they want you to show me that you know how to expand these variables in repeated multiplication. But if you forget about that and you combine them, we'll just look in your work for the repeated multiplication. Technically, this and this mean the same thing, but this is what they're looking